Hallo, it's Dumplet here. Here's an item on number theory. How many ordered pairs m²n are there, such that m and n are positive integers, and m²n is equal to 20 raised to 20? Credits to the American Online Invitational Mathematical Exam for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Alright, here we have a question, and we kind of already expect that we're going to deal with some positive integer divisors of 20 raised to 20. But there is something annoying here, is because there is this m². So we can kind of imagine this as, okay, a perfect square divisor of 20 raised to 20 times another certain divisor. So we're trying to get possibly the positive integer divisors, as well as maybe the squares, the positive divisors of 20 raised to 20 that are perfect squares. But actually we can kind of view this quotient a little bit differently and just kind of view things like one at a time. For example, in m²n is equal to 20 raised to 20, I can solve for n, and n would be equal to 20 raised to 20 divided by m². Now we can write this a little bit differently. We can write as 20 raised to 10 divided by m and then squared, like this. So now it is more understandable now, because we now know that n is equal to the square of some number. And it should be obvious that 20 raised to 10 over m, the thing inside the parenthesis here, this thing must be an integer. So I think what we have to do is just simply solve for all possible values of m, or the number of possible values of m, such that this thing inside is going to be an integer. Because n is just the square of this thing, so surely n will also be an integer. So this question kind of just reduces to a new question: find the number of positive integer divisors of 20 raised to 10, since we're dealing with positive integers m and n. So all we have to do is just make sure that this expression is an integer, a positive integer to be exact. So we're going to check on the number of positive integer divisors of 20 raised to 10. So it's just a matter of factoring now. So if you guys are not familiar on how to get the number of positive integer divisors, you guys can click this card. It is a video on getting the number of positive integer divisors, as well as the sum of the divisors, just in case you guys didn't know that yet. So click on that video and let us proceed with the solution. Alright, so 20 raised to 10, so to get the positive integer divisors, we're going to prime factorize this number. So 20, as we all know, is 2 squared times 5. So 2 squared times 5, and then this entire thing, we're going to raise it to 10. So by the laws of exponents, this would be equal to 2 raised to 20 times 5 raised to 10. Now since the exponents are 20 and 10, we simply add 1 to both of them. That's going to give us 21 and 11. And finally, we just have to take the product of these two. So 21 times 11, that's going to give us 231. And this will be our final answer. So going back to the question, since there are 231 possible values of m, and each of those 231 numbers give us an integer value of this thing inside the parentheses, and that's in effect going to give us a positive integer value for n. So there we go. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.